short number line. I think it's a little less confusing that way, and then you'll pick up on where it's concave up and concave down and increasing, decreasing when you get finished. So if I put a 0 in here, this would be negative and this would be negative, which means this is positive. Something in between here, say a 2/3 maybe, that's going to be positive, that's going to be negative, so that's a negative. If I put something like a 2, positive, 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 so that's positive, which means it's concave up from negative infinity to 1/3 and from 1 to infinity, and it's concave down from 1/3 to 1. So these are both points of inflection, 1/3 and 1, and we'd have to put it back in the original. 1 gives us, let's see, 3 minus 8 is -5, plus 6 is 1, plus 1 is 2. 1/3 is a little harder, so I'm going to get my handy dandy calculator and plug in the original function. Okay, so now I can go to the table and plug in the 1/3, which is already in there. It's about 1.4. So those are my points of inflection. Okay. So if you look at the putting all these points kind of on one number line, okay, the 1/3, the 1, and then the critical numbers, which were 0 and 1. So we have 0, 1/3, and 1 really. Then to the left of 0, remember it was decreasing to the left of 0. And then if we look at our concavity, to the left of 0 would include these numbers here, so it's concave up. Okay. In between 0 and 1/3, we'd have to check. Between 0 and 1/3, we're talking about numbers that are here, so it's concave up. Okay. And between 0 and 1/3, it is also increasing from our previous page. And then in between here, between 1/3 and 1, it's concave down, and it's increasing because 1/3 to 1 is concave down. And then to the right of 1, remember to the right of 1 would be this part, so it's concave up, and it's also increasing. So that's kind of using the chart that we looked at the beginning. And so now we know that it is concave down and increasing to the left of 0. Okay, concave down and increasing. What does that mean according to our chart? So, I'm sorry, it's decreasing and concave up. Let me write them up here. So minus plus means it's decreasing and it's concave up. Okay, so decreasing and concave up looks like this. This means it's increasing and concave down, concave up. So if it's increasing and concave up, it does this. Increasing and concave down. Okay, increasing and concave down. What does that look like? Something like that. That's increasing, but it's concave down. And then this one is increasing and concave up. So it would have to do like that. So it just gives you an idea kind of what the graph looks like. Okay, of course we can graph this. We know that it has a minimum. We already looked at that. A minimum at 0, 1. We know it has a point of inflection at 1/3, 1.4. Has a point of inflection at 1, 2. Okay, and we already know kind of what it does. We know it has to go reach a minimum here, and then it has to continue on like that, just like we showed here. You can plot some points, you can put it in your calculator, but you know it has to be smooth and continuous because it is a polynomial. Okay, so I have one more example on the video, and then we'll pick up, next time. I'm sure I'm going to hit the 50 minutes, so we'll have one more example. And this one is your favorite trig example. Okay, so again, we want to go through all the parts to graph sketching. So we want to take the first derivative, which would be negative sine of x plus 1/2. We're going to set that equal to 0. So that would be sine of x equals 1/2. And we're going to stick with 0 to 2 pi, so we're not having too many values. You can use your unit circle if you want to, but your x is going to be pi over 6 and 5 pi over 6. Those are the two values that lie between 0 and 2 pi, where the sine of x is equal to 1/2. Okay, so you're going to put these on the number line. Again, we're only going from 0 to 2 pi. We're going to pi over 6 and 5 pi over 6. And we're going to test our values. If you want to get decimal approximations for these, that's fine. Or you can just plug them in as pi over 6 and 5 pi over 6 values that are in between. That's fine too. Okay. I usually like to, so this is pi divided by 6 is about 0.5. So I'll put a little 0.5 here. 5 pi divided by 6 is about 2.6. And then, of course, 2 pi is about 6.3. So we put those values. That might help. And then you're going to put some value that's in between here, maybe a 0.2. Something in between here, maybe a 1. Something in between here, maybe a 3. And you're going to evaluate. So in our first derivative is right here. So if we take negative sine of 0.2 plus 1/2, and we'll have to make sure that our calculator is in radians. Mine is, so the negative sine of 0.2 plus 1/2, put 0.5, is about 0.3. So we know this is positive. If we put a 1 in there, negative sine of 1 plus 0.5, that is negative. If we put something like a 3, negative sine of 3 plus 0.5 is positive. So we have an alternating situation here. So we know it's increasing from 0 to pi over 6 and from 5 pi over 6 to 2 pi. And it's decreasing from pi over 6 to 5 pi over 6. There's a maximum at pi over 6, and there's a minimum at 5 pi over 6. The second derivative. Second derivative is negative cosine. If we set that equal to 0, where in between 0 and 2 pi is the cosine 0? And the cosine is 0 at pi over 2 and 3 pi over 2. So those would be our possible points of inflection. We put those on the number line. And again, just from 0 to 2 pi. And we try some values here. And we're going to be putting it back in the second derivative. Pi over 2 is about 1.6. I'm just getting decimals for these. 3 pi over 2 is about 4.7. And then 6.3. So I can try maybe a 1, maybe a 2, and maybe a 5. Back in the second derivative. So if I put my second derivative in my y equals negative cosine x, then I can go to my table and I can try all of these. A 1, what did I say? A 1, a 2, and a 5. And so I get negative, positive, negative. That's all I care about. Negative, positive, negative. So it's going to be concave down from 0 to pi over 2, concave down also from 3 pi over 2 to 2 pi, and it's going to be concave up from pi over 2 to 3 pi over 2. There's a point of inflection at pi over 2 and at 3 pi over 2. You have to put those back in the original. So I'll put in y equals cosine x plus 0.5x, and then go to my table and do pi over 2 and do 3 pi over 2, and you'll see you get about 0.8. Can't graph much better than that. And then about 2.4. So those are your points of inflection. Okay. So what does your graph do? We'll have to move to another page. So if we put on the number line, if we put all our values, 0 to 2 pi, and we're going to put our critical numbers, which are pi over 6 and 5 pi over 6, and we're going to put our we'll also put our points of inflection, which are pi over 2 and 3 pi over 2. Okay, so where would those go? Okay, so I have pi over 6 and 5 pi over 6, and pi over 2 and 3 pi over 2. So we'll have pi over 6 first. Okay, then we'll have pi over 2, 5 pi over 6, and the other one is 3 pi over 2. And then you'll test your values. And we've already done pi over 6 is about 0.5. We've already done that. Pi over 2 is about 1.6. 5 pi over 6 is 2.6. 3 pi over 2 is 4.7. And then 6.3. So I can test 0.2, 1, and I can test 2. Actually, I don't even have to test them. I can just put the values in. From 0 to pi over 6, we know it's increasing, and we know it is concave down. From pi over 6 to pi over 2, we know it's decreasing, and we know it's concave down. From pi over 2 to 5 pi over 6, we know it is decreasing, and we know it's concave up. From 5 pi over 6 to 3 pi over 2, we know it's going to be increasing and concave up. And then finally, from 3 pi over 2 to 2 pi, we know it's increasing and concave down. That's just coming straight off of our number lines for each one. Okay, so that means this is going to be increasing and concave down, decreasing and concave down, decreasing and concave up, increasing and concave up, increasing and concave down. So what does the graph look like just in general? It's going to be increasing and concave down, then it's going to have to do this. Okay? If it's going to be decreasing and concave down, it's going to have to do this. Decreasing and concave up, what does that mean? If decreasing and concave up would have to be like, what was our decreasing and concave up? Decreasing concave up looks like this, okay? And then increasing and concave up would be here. And then increasing and concave down would put us again like that, okay? And that's what you would expect from a trig function, okay? So we already know that we have a, if I graph this as a trig function to 2 pi, we know we have a maximum at pi over 6, so somewhere in here we have a maximum. And then we have a minimum at 5 pi over 6, so somewhere over here we have a minimum, okay? We know the concavity intervals, we know points of inflection are at pi over 2, 0.8. Okay, you know we had a maximum at pi over 6, so it's going to have to be higher. So it's going to look, let me do my other point of inflection, 3 pi over 2, 2.4. So it'd be up here. Okay, so it's going to